this holographic idea of the universe is inspired by the thermodynamics of a black hole. So the maximum entropy in any region is ultimately scaled with the radius squared and not cubed. What this means is that radius cubed is a three-dimensional version of radius squared. It's ultimately trying to understand the surface area of a sphere, whereas radius squared tries to understand the surface area of a circle. The radius and the circumference of a circle, in all cases, are related by a constant. Okay, you can say that's the center of a sphere or the center point of a circle. You see, there's always a constant on a circle, which is its center point from where the radius comes out of and into the circumference. And this constant is the reference point, which the surface area extending from the point closest to the constant, which is the beginning of the radius, and out to the furthest point away from the constant, which is the point on the circumference. And so in a circle, in a two-dimensional figure, the constant is always at the center of a circle, denoted by the radius, which is half a diameter. But on a sphere, the constant is any point on the surface of the sphere is its center point. And any point on the circumference of a sphere, pick out any point on it and stop at that point, and it becomes the constant from which the surface area of the sphere relates to. Now, on an ordinary visual demonstration, you can pick out any point on the circumference of a sphere, and that becomes the constant. The true constant on a sphere is not any point that you pick out. It's actually the point that you don't pick out. It's actually the point that's hidden. It's always the point at the back of the sphere. What's behind the sphere on the other side, that every time you look, there's always a side missing. You see, and this is why a three-dimensional sphere is always fundamentally a two-dimensional circle. It's because there's always this inherent asymmetry, a blind spot in relation to the observer, that the observer observes or perceives a figure on a two-dimensional spectrum, and then always sees that figure as having no extension beyond itself, or that there is always an aspect of that figure which is a limitation of itself. And therefore, if you look at a three-dimensional figure where it has an extension of itself outside of itself, and while maintaining its identity, you still see that there is a fundamental, one-dimensional or even zero-dimensional property in it, which is never observable. And we observe this in the phenomena of black holes out in space.